Hello and welcome back to this channel once again. In today's video, we are going to focus on the delta neighborhood of a point as well as the deleted delta neighborhood of a point. Now, if you are new here, make sure you subscribe to this channel, like this video and share this video to all your friends. So let's get into today's lesson. Now, the neighborhood of a point is referred to as the open interval containing that point, where one can move some distance away from that point in any direction without leaving the interval. Now let's take the definition again. The neighborhood of a point is the open interval containing that point, where one can move some distance in any direction away from that point without leaving the interval. Now let A be a point in R. So let A be a point in R. So A is a real number and delta be a positive real number. Now delta here is a very small positive real number. Now if that is the case, then we say that the neighborhood of A, which is sometimes referred to as the delta neighborhood of the point A, is the open interval of the form A minus delta, A plus delta. Now let's represent this on the number line. So we have this to be our real number line. We have point A, and then we want to move some distance away from this point to the right. Now this distance is called delta. Therefore, A plus delta is A plus delta. And then we do same to the left. We move some distance, say delta, to the left along the number line, and that becomes A minus delta. Now, the open interval A minus delta, A plus delta, is what we call the delta neighborhood of the point A centered at A. So delta neighborhood of point A. Now this explains the fact that the delta neighborhood of point A is said to be the open interval containing A, where one can move some distance away from A in any direction, be it to the right or to the left, without leaving the interval, that is A minus delta, A plus delta. Now let's take key notice of some important points. 1. Since the interval is open, the end point A minus delta, A plus delta are not part of the set. They are not part of the set. 2. The interval is centered at A, which means that A is part of the set. So the interval is centered at A. And then lastly, the length of the interval is given by the absolute value of A minus B, or better still, the absolute value of B minus A. Now on the real number line, we have A minus delta to be A, and then A plus delta to be B. Now in that case, let's substitute these values here. So assuming that we are focusing on A minus B, then we have the absolute value of A minus B. So A is A minus delta minus into brackets B, which is A plus delta. Now let's simplify this. So this becomes, we have the absolute value of A minus delta. Now we multiply negative 1 across, and that becomes negative A, negative delta. Let's simplify further. A minus A is 0. Negative delta minus delta is negative 2 delta. And then we pull out delta, and then we have the absolute value of negative 2. Now the absolute value of negative 2 is 2. Therefore, the length of the interval is 2 delta. Now let's move on as we solve an example. Notice that since a minus delta and a plus delta are not part of the set, we are going to represent each of them with an open circle. So for this example, we are asked to find the open interval, the length and center given by the 3 neighborhood of 1. So find the open interval, the length and center given by the 3 neighborhood of 1. Now to solve this question, the first thing we are supposed to do is to define the values or the numbers we have in here. Now let's consider this. Now if we have the delta neighborhood of A, then we can equate that to what we have in the question, which is the 3 neighborhood of 1. Now if you should do this, then you realize that delta is equal to 3 and A is equal to 1. Now we know that the delta neighborhood of A is given by the open interval. The delta neighborhood of A is given by the open interval A minus delta, A plus delta. So in the question, if we are given the 3 neighborhood of A, then that will be given by the open interval. In place of A, we have 1 minus, in place of delta, we have 3. So we have 1 minus 3, we have 1 minus 3, and then 1 plus 3. Now let's simplify this. 1 minus 3 is negative 2, and then 1 plus 3 is 4. Therefore, the 3 neighborhood of 1 is given by the open interval negative 2, 4. So this is the open interval of the 3 neighborhood of 1. Now we can represent this on the real number line. So we are going to have A, which is 1, and then we have 4 on the right, and then negative 2 on the left. And this interval is called the 3 neighborhood of 1. Notice that since the interval is open, negative 2 and 4 are not parts of the set. So this is the open interval given by 3 neighborhood of 1. Next, we are asked to find the length of the interval. Now the length of the interval is given by the absolute value of A minus B. Now A is given as negative 2, and then B is equal to 4. So let's substitute this value in here. Therefore, we have the length of the interval equal to the absolute value of negative 2 minus 4. Now negative 2 minus 4 is equal to negative 6, and the absolute value of negative 6 is 6. Therefore, the length of the interval is 6. C. Now the center. So the center of the interval is equal to A, and here we have A equals 1. Therefore, the open interval negative 2, 4 is centered at 1. So mathematically, the delta neighborhood of A, which is given by the open interval A minus delta, A plus delta, can as well be represented as A minus delta less than X less than A plus delta, which defines the set of all points X such that the absolute value of X minus A is less than delta, where A is a member of R and delta is greater than 0. So now let's move on to the deleted delta neighborhood of the point A. So the deleted delta neighborhood of a point A is the open interval given by A minus delta, A plus delta, where A is not part of the set, or better still, A is not part of the interval. Now let's represent this on the real number line. So assuming we have this to be our real number line, we have this to be point A, and then we are going to move some distance, say delta, away from A to the right, and thus A plus delta is A plus delta, and then we move some distance, delta, also to the left, and thus A minus delta is equal to A minus delta. So this time, not only A minus delta and A plus delta are excluded from the interval. Now, as the name goes, the deleted delta neighborhood of A. Now, this simply means that A is deleted from the set, or better still, from the interval. Therefore, A is also not part of the interval. So the endpoints A minus delta and A plus delta are not part of the interval, as well as A is also not part of the interval. So the actual interval given by the deleted delta neighborhood of A is the open interval. So between A minus delta and A, union between A and A plus delta. So this is the open interval given by the deleted delta neighborhood of A. Now notice that since A is deleted from the set, A is not part of the interval. A is not part of the set or the interval. The center of the interval still remains A, and lastly, the length of the interval is given by A minus B, which is equal to 2 times delta. Now mathematically, the deleted delta neighborhood of the point A, which is given by the open interval A minus delta A union A plus delta, defines the set of all points x such that 0 is less than the absolute value of x minus A is less than delta, where A is an element of R and delta is greater than 0. Now let's solve an example on this. So focusing on the same example, this time we want to find the open interval, the length and center given by the deleted 3 neighborhood of 1. Now you realize that delta is equal to 3 and A is equal to 1. So how do we find the open interval given by the deleted 3 neighborhood of 1? Now from the previous section, we know that the deleted delta neighborhood of A is given by the open interval A minus delta A union A A plus delta. Now, since we have in this question deleted 3 neighborhood of 1, and since we know that delta is equal to 3 and then A is equal to 1, let's substitute the values of delta and A into this interval. So A is 1, delta is 3, union 1, 1 plus 3. Now let's simplify this. So 1 minus 3 is negative 2. 1 plus 3 is 4. Therefore, the deleted 3 neighborhood of 1 is given by the open interval negative 2, 1, union 1, 4. Now let's represent this on the real number line. So we have this to be A, and A is 1, so we have 1. On the right, we have 4. On the left, we have negative 2. Now, since this interval is open, we are going to have an open circle on negative 2 and then 1. And then this interval is also open, so an open circle on 1 and 4. Therefore, the interval given by the deleted 3 neighborhood of 1 is the interval between negative 2 and 1, union 1 and 4. So that is the interval. B. We are going to find the length of the interval. Now we know that the length of the interval is given by the absolute value of A minus B, and that has already been simplified as 2 delta. So we have 2 times delta, which is 3. So 2 times 3 is equal to 6. Therefore, the length of the interval is equal to 6. And then C, we are asked to find the center of the interval. So the center of the interval is given as A, and we have A to be 1. Therefore, the interval given by the deleted 3 neighborhood of 1 is centered at 1. So now let's move on as we discuss the open sets as well as the closed sets, and we are going to look at a couple of examples. So considering the set of real numbers, a set is said to be open if it does not contain any of its boundary points. So a set is said to be open if it does not contain any of its boundary points. Now let's look at these examples. Let's consider the first one. Here we have the open interval 1, 2. So what do you think are the boundary points of this interval? Now, given an interval, the boundary points are normally the points on the extreme ends. So 1 is a boundary point as well as 2 is a boundary point. So the boundary points here are 1 and 2. Now the condition for a set to be open is such that if it does not contain any of its boundary points, then we say that that interval is open. Now looking at this open interval, you realize that 1 and 2, which are boundary points, are not part of the set. Hence we say that this is an open set, simply because the boundary points 1 and 2 are not part of the set. Now let's move on to B. So for B, we have 2 open intervals. We have 1, 3, union 4, 5. Now you realize that the boundary points 1, 3 are not part of this interval, as well as the boundary points 4, 5 are also not part of this interval. Hence we say that this is an open set. notice that the union of two or more open sets is also an open set. Now let's move on to C. So here we have an open interval 4 and then a closed interval infinity. Now, since we are considering the real number system, infinity is not a member of the real number system. So infinity, or better still, positive infinity, is not a member of the real number system. Negative infinity, on the other hand, is also not a member of the real number system. Now, if you want to extend the real number line so that you have negative infinity and infinity, then we call that the extended real line. Now, in this extended real line, negative infinity and infinity are parts of the set and hence are boundary points. Now, since we are going to limit ourselves to the real number system, it means that infinity is not part of the real number system, hence infinity cannot be a boundary point. Now, in that case, the only boundary point for this interval is 4, and since 4 is not part of this set because we have an open interval here and 4 is not part of this set, it means that this is an open set. Remember, for an open set, it does not contain any of its boundary points. Now to the last one, which is D. You realize that we have an open interval 2, 3, and a closed interval. Now looking at this interval, you realize that 3, which is a boundary point, is part of the set. Now since 3 is part of the set, then it means that this interval is not an open set. Now to a closed set. Also considering the set of real numbers, a set is said to be closed if it contains all its boundary points. So a set is said to be closed if it contains all its boundary points. Now let's investigate these examples. A. Now we have a closed interval 2, 4. Now considering this interval, 2 and 4, which are the boundary points, are part of the set. Now since 2 and 4 are part of the sets, it means that this interval is a closed set. So this interval is a closed set simply because all its boundary points, 2 and 4, are part of the set. Now let's move on to B. So here the interval is closed at 1 and the interval is open at 5. Now since the interval is open at 5, it means that the boundary point 5 is not part of the set. Therefore, this interval is not a closed set. This interval is not a closed set. Now to the last one, which is C. The interval is closed at 2 and open at infinity. Now because we are considering a set of real numbers or the real number system, infinity is not a member of the real number system, which means that infinity is not or cannot be a boundary point. Now if infinity cannot be a boundary point, it means that the only boundary point in this interval is 2, and 2 is part of the set. Now since 2 is part of the set, it means that this set is a closed set. So that's it for today's video. Thanks for watching and see you in my next video. Bye bye.